we're going to be transitioning into a presentation by Rahul Somasunderam from Netflix, who is going to be telling us exactly how Netflix builds code. I can't wait for this presentation. And Rahul, if you're ready, we can jump right in.
Hello, my name is Rahul. I work on CI at Netflix. I'm going to talk to you about how we build code. Most teams have at least a few different roles. Typically, you aim for hiring people with a T-shaped experience. They have a depth of expertise in their primary job and enough experience to get by in other areas. Their teammates will have expertise in those areas and will cover for whatever they miss. To go from one team to many such teams, you need to replicate these teams, and that is often very hard. We try to solve this problem by using what we call full cycle development. You don't need a depth of experience in areas that are shared across teams like infrastructure, CI, CD, build systems, networking, metrics. And that is not a problem because we have central teams. These central teams develop tools that solve these problems and help these teams solve problems independently. This makes it easier for us to scale orgs. You hire people who have great development skills and just enough understanding of the tools that we share. I apologize for the next 4 slides where I've got some really bad graphics, but let's get on with it. So this is what a project typically does, in that you have a beginning and eventually you have an end. And in between this, we repeatedly develop new features, deploy them, and observe and support them. Every so often, we tend to look at all the versions of an API or a library or a tool that our users depend on. And then we decide to deprecate the older versions. And that helps us reduce our support burden. Deprecations are an essential part of the lifecycle of software. It's tempting to think that we have teams that work in these individual areas. There are clear boundaries of what each of these central teams does. In reality, all central teams have some role to play throughout the lifecycle of software. One of the guiding principles for central teams at Netflix is guardrails, not gates. That means central teams will provide guidance and build tools that make risky tasks safer for other teams. We prefer to not stop teams from doing something that falls outside our recommendations. As a result, we do not have approved tools and languages. Instead, we have the paved road. But to appreciate the paved road, you need to first understand the unpaved road. This picture is from the 2012 London Olympics for cross-country mountain biking. You don't see mechanics, you don't see medics. They're there, you just don't see them. If you're doing this as a hobby, you sure need to carry a lot of tools and spares with you. And this is at the UCI Worlds from the same year. There is a team car right next to the riders. If something goes wrong, either mechanically or as a minor injury to the rider, they can fix things right then and there, sometimes even as the rider is still riding. If you're doing this as a hobby, you can phone a friend to come pick you up if something goes horribly wrong. That's exactly what the paved road looks like in software development. At Netflix, we have something in our culture deck called freedom and responsibility. Each team is free to decide how to accomplish their goals. They have the responsibility to act in the company's best interest. That means you don't have to go on the paved road, but if you are on the paved road, you get amazing support from central teams. My team works on continuous integration and is one of those central teams. Many central teams support some subset of everyone whose role is engineer or close enough. My team supports every one of them. There is a lot going on here. Many of these tools should be familiar to you. Because we allow people to be on the unpaved road, any list we make can never be exhaustive. The paved road is not a sign of the importance of things. It mostly corresponds to the impact we can achieve as central teams. Many of these tools are open source. Some are commodity products that anyone can access. A few are internal tools, but there isn't too much that should be inaccessible to people outside of Netflix. There are similar open source and commercial solutions available if you choose to take inspiration from this. For the purpose of this talk, let's take this path. We can briefly see what all the tools look like, but spend more time on this one path. So Gradle has been around since 2007. It's a solid build tool that uses a slightly different way of doing things. Its predecessors were Ant and Maven. Ant was very open as a scripting solution that used XML to describe the build. Maven brought some structure using its repository and lifecycle phases. Gradle brings in structure using its directed acyclical graph and a very simple plugin model. Nebula is Netflix's take on what Gradle builds should be like. It is a custom distribution of Gradle that we've developed. Large parts of it are open source, but there are some bits and pieces that are internal to Netflix. The non-OSS parts mostly deal with getting to Netflix's repositories for downloading and publishing artifacts. It's as simple as adding one line to your build.gradle. The Nebula plugin applies a lot of open source Nebula plugins to your project and configures them correctly. But it also checks what other plugins are applied and configures them in a way that's appropriate for building at Netflix. It also configures publishing correctly. Most teams apply netflix.nebula to their all projects block and then add just a simpler plugin on each sub-project. That could be a Spring Boot plugin or a Java library plugin. If you're developing a Node app, it's very likely you're building with NPM. And we have a dev dependency for something similar to netflix.nebula that does some of the same things, but for Node and NPM. As you develop code, you push it to all your projects, Git repository, and some teams rely on pull requests, some don't. Some will use forks, others won't. Some of you might prefer to use monorepos, but at Netflix, we prefer to have a repository per releasable group. What is a releasable group? If you're building microservices, you might have a user service and a movie service. These two have different release cadences, so you're going to release them separately. And so they belong in different repositories. However, when you release your user service, you might be releasing the user Java client and the user Node client at the same time. So these two would belong in the same repository as the user service. Once your commit occurs, it's time for Jenkins to pick up your code and build it. Configuring everything correctly with Jenkins is hard for many engineers. So we built something called Rocket CI. It is a layer on top of Jenkins that makes it easy to do that at Netflix. It's opinionated, but it's easier to maintain. You can curl an endpoint to set up a Jenkins job that does everything correctly and specify what kind of builds you want. Only the main branch, or only pull requests, or only tags, or a combination of these. Most build configurations are simple enough that we expose a handful of properties through a YAML file that's in the project's repository. The build itself is a shell script that can be checked in. If you have as many repositories as we do, and you push code as often as we do, webhooks become unreliable as a way to trigger builds. Even falling back to polling can result in service degradation. So we built plugins for our Bitbucket, Jenkins, Artifactory, and Spinnaker to rely on SNS and SQS. Whenever a code event occurs, the plugin for Bitbucket emits an event that can be consumed by any service. Rocket consumes that event and triggers a build. Whenever a build event occurs, Rocket emits that event on the SNS topic. Once your build succeeds, it produces an artifact. It could be a Debian or a Docker image or something toolchain specific, like an NPM package or a jar. Sometimes it is even just a tar file. If it is a Docker image, it goes to the Titus container registry. If not, it typically goes to Artifactory. If you're building a library or CLI, your journey mostly ends here. However, it's more likely that you're building a service and need to deploy it somewhere. When an artifact is published to Artifactory, our plugin there emits an artifact event. Spinnaker could consume either the build event or the artifact event and begin deploying our code. We are going to choose the artifact event for this talk. Keeping projects healthy is something we can easily do during the CI phase. We have a system that's based on enrollments and Docker images that works a lot like Dependabot, but does more than dependency updates. If a central team can define a migration in a Docker image, they can use this to effect change in all repositories at Netflix and send pull requests to teams to have them review and merge these. Some kinds of changes are routine enough that we have a lot of confidence in them, and we merge these changes on a successful PR build. Examples of these are tool version upgrades, dependency updates, and lint fixes. For a long time, the way to do CD in Spinnaker was to define a pipeline. More recently, Spinnaker introduced something called managed delivery. For many applications, this is an adequate solution. And if it is adequate, you do not need to create pipelines for it. You'd be familiar with how Docker images are immutable. We try to do something similar for EC2 deployments. The Debians that we built earlier are baked into Amazon machine images. Next step is the deployment itself. Depending on what you're doing, you might either deploy to Titus if it is a Docker image. If it's not, it's very likely you're deploying to EC2. Now that your code is running, you need to monitor it. We have Atlas reporters for most of our runtimes. These send metrics to the Atlas service. From there, it can be used to trigger alerts or create dashboards. Astrid helps us keep track of what's running. During a bake, it will gather information on what Debians go into each AMI. It can find out from metadata that we publish what goes into each Debian. It knows about each jar and npm package that we are running in addition to the Debians. It can do the same thing for Docker layers too. Once a quarter, teams that publish libraries will get together and say what the minimum version of their library should be. Astrid will take this input and start sending nudges to anyone who consumes the library, pointing to where they are using an older version. This allows teams to update their dependencies, and if the version is too old, we can prevent new deploys from happening. But it doesn't always have to happen once a quarter. For example, if you depend on an OSS library for which a CVE has been published for a specific version, we can block your deploys until you update to a safe version. This can happen at any time. Our build tooling also has a way to check for this and can prevent your builds from happening. As you can imagine, setting up all of this for every project can be a huge task. We have a tool for this called Newt. You can think of Newt as Yeoman plus SDKman plus NVM plus RVM plus a lot more. It has a templating system like Yeoman does that helps you bootstrap your repository, but it also knows how to talk to all these other services and configure them correctly. Further, it also wraps build tools, so you can configure your repository with information on what build tool needs to be selected. For example, you could say you want node 12.16.2 and npm 6.14.4. Then you can call Newt build, and it will download the right tools and call the appropriate command for your build tool. This means that when you check out a new repository, you don't need to figure out how to build it. For most app types, you can go from wanting to start a new app to having a Hello World up and running in production in about 15 minutes. So that's the summary of what we do. I look forward to your questions.
Awesome, Rahul. Thank you so much for coming out here. We really appreciate getting some more perspective on what's happening behind the guise of Netflix. It's wonderful to have some perspective on tooling systems that aren't, conducted entirely in the open and chased after elsewhere. It's neat to see the entire suite of tools that's accessible there. Essentially, how often would you say you guys actually manage to integrate new tooling into your build system? Is it a really slow process, or are you guys cranking things out on a regular basis?
So with regard to new tooling, the paved road, I would say we are very cautious about it. And we need to guarantee that there is a system of support for that new tool. And there are examples where there are tools that are not supported by a central team that are being used. For example, a lot of people who do machine learning are using Python-based systems, and that is not big enough a use case that a central team steps in to support it. And we use a term called local central teams. So these teams would use our existing tooling and integrate tool chain specific bits and pieces into the system. So for a central team, there is no visibility into, there's no need to understand what's happening for Python as long as we maintain our interfaces correctly. But someone who's working on machine learning, it's the same thing whether they're working at Netflix or they're working at a different company which has got pretty much whatever the standard tooling for Python and machine learning is.
Awesome. So we do have a couple of questions that have come in. It sounds like Netflix has a many repo setup, and this was done intentionally. Could you elaborate on why this choice was made and its or the benefits that you've seen over a mono repo?
So I don't think you have clear benefits. It's mostly you are speculating on where you want to invest your effort. With a mono repo, you are spending a lot of effort into trying to build just the right part. So if you have 50,000 source files and you change one, it's likely you need to run just 100 tests to be sure what is being changed does not break things. And the good thing about mono repos is whoever makes a change in any part of the system is in a way responsible for making sure everything else works. In our case, we decouple this thing, and if all you're doing is releasing a library, then go ahead, release a library, and we will eventually integrate that with everyone else's code. So we would send a pull request to everyone who consumes that, and either the pull request build passes and your change got promoted to production, or the pull request fails, and that is the promise of a conversation between two teams about what changed and what needs to be done. So there is, we found that for our culture of how things should be done, this was the right solution. And if your culture is very different, then maybe mono repos are the right solution for you. I don't think there's a clear winner between the two.
I think it's clear that there are no winners in that decision, and that in general you're all working with source code. So there's no way to fight that battle. So a couple more questions. I expect Netflix has to deal with a lot of device-specific build systems, and I can attest for that for the 6 devices in my house that have to run Netflix. For example, iOS, Android, Samsung TV, and other devices. What's the percentage age of the code base? Or sorry, what percentage age of the code base does the paved road cover? For example, is 60% of what you support just for the server side?
So if you're building services, you can be 100% on the paved road. If you are not building services, for example, you're building the iOS app, let's take that as an example. There are a few things that are covered, like version control is covered. Jenkins and our internal tooling called Rocket is covered. But then there is the part about you need macOS agents to build your code. You need Xcode, and you need a bunch of iOS-specific tooling for all of this to work. So those are the places where we would say that the iOS team has to go off-road and build their own support for it. And it makes sense for that team to have expertise in that, because out of hundreds of teams at Netflix, there is possibly like 2 or 3 teams that need iOS support, and they build it themselves. Whereas for something that is an org that supports thousands of engineers, it is not very useful for us to know everything about iOS.
Sorry, I was stuck on the idea that only 2 of your teams need iOS support. I'm really impressed by either an expansive server infrastructure that allows that to happen, or the fact that you've abstracted away so much of that. That's phenomenal. So the next question is, I expect Netflix, oh, sorry, that's exactly the same question. I've got to archive these things. Is Rocket CI open source?
It is not open source. We are in conversation with Spinnaker to take bits and pieces of it and extract them into a spec that allows this to happen. And the reason we don't look forward to open sourcing Rocket CI is it has a lot of internal dependencies on Netflix systems, like our authentication system, our logging system, our metric system, and we don't see a way to open source it without abstracting away all of those things. Because if we do it without that, then it's unlikely that someone else will be able to use it.
Awesome. I'm going to do one last check for open questions. First of all, I want to thank you for coming out and speaking to us. We really appreciate it.
Thank you for having me. Bye.